Hello and welcome to this lesson on the limitations of the particle model. Today, we will learn to recognize the limitations of the simple particle model in accurately representing the behavior and properties of real substances. We will explore how this model oversimplifies certain aspects of real substances and identify where it falls short. So far, you've become familiar with the three states of matter: solids, liquids, and gases. You understand the processes by which a substance changes state, such as melting, boiling, freezing, and condensing. We've also covered the concept of intermolecular bonds, the attractions between particles that play a crucial role in determining the state of matter. Building on this foundation, today's lesson will deepen our chemical understanding by highlighting the limitations of the simple particle model. While it provides a useful starting point for visualizing particles, recognizing its limitations will allow us to appreciate the complexities of real substances. This, in turn, will advance our understanding by bridging the gap between simplified models and the actual behavior of materials in various states. In our exploration of the limitations of the simple particle model, let's delve deeper into some critical aspects. Firstly, the model represents all particles as identical solid spheres. However, in reality, particles vary greatly in size, shape, and complexity. For instance, a molecule of water, H2O, is bent in shape, while a molecule of methane, CH4, is tetrahedral. Different shapes affect how these molecules interact with each other. Furthermore, the model depicts particles as solid and rigid spheres, but in reality, atoms are mostly free space. Secondly, there is no structural diversity. The simple particle model does not account for diverse structures and arrangements found in real substances. It doesn't account for the differences in bonding types and strengths between particles. Ionic, metallic, and covalent bonds are fundamentally different. Diamond has a very different structure compared to graphite, yet both are forms of carbon. These structural differences lead to vastly different physical properties, which the simple particle model fails to represent. Furthermore, the simple particle model does not accurately depict the space between particles. For example, the distance between atoms in helium gas is about 55 times larger than the diameter of the helium atoms themselves. Such large differences are challenging to depict accurately in simple particle model diagrams. Lastly, in the simple particle model, particles are depicted without any forces acting between them. In a gas like helium, particles are depicted as far apart and moving freely, but this simple view misses the occasional collisions and that there still are some weak attraction forces between particles. In today's lesson, we delved into the limitations of the simple particle model in accurately representing the behavior and properties of real substances. We identified several critical shortcomings of this model. Firstly, it oversimplifies particles as uniform solid spheres, not accounting for the varied shape and sizes of molecules. We also discussed how the model fails to represent the structural diversity of substances, exemplified by the different forms of carbon like diamond and graphite. Moreover, the simple particle model fails to accurately depict space between particles and falls short in its consideration of intermolecular forces,